October 3rd, 2025, NASA's Perseverance rover, tirelessly exploring the Martian terrain, snapped a series of images that unveiled a cosmic enigma, 3 glimpses of the interstellar wanderer Atlas. The shots weren't crystal clear, but they were enough to ignite curiosity. Enter Simeon Schmaus, a dedicated astrophotographer who meticulously stacked 20 of these rover images to reveal a faint, tantalizing smudge of light precisely where this celestial visitor was predicted to appear. The discovery has sparked a wildfire of excitement, with enthusiasts dissecting, debating, and marveling over what this faint glow might mean. But the story takes a peculiar turn. On that very same day, NASA made the surprising decision to furlough 15,000 employees. Coincidence, perhaps? Meanwhile, the Mars Reconnaissance Orbiter, equipped with a high-resolution camera boasting 30 times the clarity of Perseverance's lens, was perfectly positioned to capture a breathtaking once-in-a-lifetime view of Atlas. The European Space Agency's Mars Express and ExoMars orbiters were also in prime position, their instruments trained on the skies. So, where are those images? The silence is deafening and the mystery deepens. Even more intriguing, remote viewers claimed back in August to have detected something extraordinary. A device no larger than a thumb drive, deliberately embedded within an ancient comet, emitting cryptic impulses. These claims surfaced months before telescopes began picking up chemical anomalies that defy explanation. What is Atlas, a natural comet, or something far more extraordinary? This 2-part video dives into the heart of this cosmic puzzle. The first half unravels the enigma of Three-Eye Atlas and the latest revelations surrounding it. The second half brings you the week's most captivating space news. Want to skip to a specific part? Check the timestamps in the description. If this mystery has you hooked, smash that like button and hit subscribe to stay in the loop. Drop a comment below. Tell me where you're watching from, what time it is there, and what you think Atlas truly is, a cosmic coincidence or something more. Help our community grow. Share this video on X, Facebook, Reddit, or your favorite messaging app. Thank you for always having our back and joining us on this journey into the unknown. Chapter 1: The Enigma in the Martian Sky. 2 days ago, a single post on X ignited a firestorm that shook the astronomy world to its core. A user named UFO Mania shared an image with a caption that stopped the internet in its tracks. The newest and closest of the 3 Atlas objects passing by Mars is no comet. It's perfectly cylindrical. The image revealed an elongated, almost artificial-looking object streaking through the Martian sky during its flyby. Within hours, thousands had shared the post, rippling across the digital cosmos like a shockwave. This wasn't just another wild internet theory. This was different. The coordinates aligned. The timing was precise. And most chillingly, the deafening silence from official sources matched perfectly. On October 3rd, 2025, when 3-2 Atlas made its closest approach to Mars, 29 million kilometers away, humanity's most advanced spacecraft were poised for a historic moment. NASA's Mars Reconnaissance Orbiter, armed with its high-resolution imaging experiment camera, capable of capturing details 30 times sharper than Perseverance's lens, was perfectly positioned. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter had their cutting-edge instruments locked on the same celestial target. Multiple spacecraft, multiple angles, the sharpest view ever of an interstellar visitor. And yet, nothing. No images, no data, just an eerie void where answers should have been. Into that void stepped voices too compelling to dismiss. An account called 3I Atlas Anomaly began posting with a precision that cut through the noise of typical conspiracy chatter. Their updates were meticulous, 10 specific observations, each backed by hard data. They cited a carbon dioxide-rich coma detected by the James Webb Space Telescope water and hydroxyl emissions picked up by the Swift Observatory and polarimetric anomalies revealing a negative 2.77% polarization at a 7-ground phase angle, an unprecedented signature for any known asteroid or comet. This wasn't speculation. It was science grounded in real instruments and published observations. Then came a post that made even the staunchest skeptics pause. A user named Moneypenny, identifying as a plasma phenomena expert and former BBC journalist, dropped a bombshell. She claimed that Stefan Burns, a leading cosmologist, believes 30 Atlas is no ordinary object. It's intelligent, enveloped in dusty plasma, and exhibiting signs of consciousness already communicating with Earth and other planets. Consciousness. Communication. The words hung in the air like a challenge to reason. This wasn't some obscure corner of the internet. This was a credentialed voice, her investigative journalism background lending weight to her claims. And then she added a detail that sent shivers through the online community. We can no longer observe it. It's too close to the sun. We won't see it again until December. 3 months of darkness, 3 months of the object hidden behind the sun's glare, invisible to every telescope on Earth. If its trajectory shifts, we won't know until it reemerges. As if that weren't enough, a UFO investigator and journalist named John Stewart, not the comedian, posted a cryptic warning that felt ripped from the pages of an ancient prophecy. My source has gone dark. NASA is shutting down, and even Congress is in recess. If Threeless activates ancient texts, warn the sky will burn with knowing light, and the world will forget its reflection. He called it prophecy. Agencies called it protocol. He called it imminent. Hashtags like Major Vatican Files and Dawang the Harbinger began trending alongside technical astronomical discussions, blurring the line between science and myth. How do you sift truth from chaos when the chaos itself might be the truth? Here's the uncomfortable reality. In the 48 hours since these posts exploded, not a single official image from the Mars flyby has surfaced. Not from NASA, not from ESA, not from China's Tianwen-1 mission, or the UAE's Hope orbiter, all of which had their eyes on the sky. The only visual evidence we have comes from astrophotographer Simeon Schmaus, who painstakingly stacked 20 images from Perseverance's Mastcam Z and found a faint smudge of light in the constellation Corona Borealis, right where 3 Atlas was expected. A faint smudge that's all we have from humanity's closest encounter with an interstellar visitor captured by spacecraft that can resolve features smaller than a car on Mars's surface. Unless, of course, they saw something else, something they chose to keep hidden. The 3I Atlas anomaly account didn't stop there. Their updates grew sharper, more urgent. Unexpected brightening 3 Atlas is outshining predictions, suggesting volatile or highly efficient outgassing mechanisms atypical for its distance. They noted that as the object slips behind the sun, ground-based observations are cut off. But ESA is redirecting Mars orbiters to monitor it during the October 3rd flyby at roughly 30 million kilometers. Every detail they shared was verifiable, rooted in published data. Yet their conclusion was inescapable. This object does not behave like a comet. And then came the shape. Independent amateur astronomers working separately reported the same anomaly. When they enhanced their images, stripped away background stars, and boosted contrast, what emerged wasn't the fuzzy, irregular cloud of a typical comet's coma. It was smooth, elongated, almost unnaturally geometric, perfectly cylindrical, just as UFO mania claimed. Skeptics will argue that elongation can be an artifact of motion image processing or light scattering through a coma. They're not wrong, it's possible. But it's also possible it's real. We know this because Oumuamua, the first interstellar visitor, was also elongated, pancake-shaped to some, cigar-shaped to others, but undeniably non-spherical. So when 3-2 Atlas shows similar traits, when multiple observers confirm its geometric precision, and when official channels remain silent, what are we left to believe? NASA's response is measured almost too careful. 3-2 Atlas poses no threat to Earth. Its trajectory keeps it hundreds of millions of kilometers away, swinging closest to the Sun on October 30th, before vanishing into the cosmos, never to return. All true, all sidestepping the real question burning in everyone's minds. What is it, and why? On the day we should have seen it in unprecedented detail. Did NASA furlough 15,000 employees, leaving the world with nothing but a faint smudge and a growing sense that the truth is just out of reach? Chapter 2. The Remote Viewer's Revelation. In August 2025, 2 months before the Mars flyby, before NASA's mysterious shutdown, and before viral posts set the internet ablaze, a quiet but seismic event unfolded in the shadows. It began with Birdie Jorski, a name that carries weight in the world of remote viewing. With nearly 3 decades as a professional remote viewer, a former vice president of the Farsight Institute, and a master's degree in digital forensics, Birdie is no stranger to precision or skepticism. She's not chasing clout or spinning wild tales. What she uncovered that summer day demands attention. A friend handed her a set of coordinates, nothing more. No context, no images, no hints. This is a gold standard of remote viewing, a blind target, ensuring the viewer's perceptions are untainted by bias. Birdie settled into her protocol, her mind a blank canvas, and began to describe what she saw. At first it was simple, an object moving through the vastness of space, ancient, icy, rocky, a textbook comet, or so it seemed. But as she probed deeper, something shifted. There's something not completely natural, she later shared on a podcast, her voice steady but tinged with unease. It was like finding a fingerprint on a pristine surface, a deliberate mark where randomness should reign. She pressed further, and that's when it emerged, a device no larger than a thumb drive intentionally embedded within the object, not resting on its surface, but buried inside as if someone or something had drilled into this ancient icy rock with purpose. It's encoded with information, she said, like an archive, a message in a bottle. But it's not just a message, it's technology. Pause and let that sink in. Not a gleaming spaceship or extraterrestrial beings, but a tiny, ancient device hidden within a comet that's been drifting through the cosmos for billions of years. The object itself is billions of years old, Birdie continued, and the device inside it is just as ancient. Did some civilization light years away send a probe to embed this technology, knowing it would travel forever? The idea isn't as far-fetched as it sounds. Humanity has done something similar. The Voyager probes carry golden records, time capsules crafted to endure billions of years, carrying our story to anyone who might find them. The concept of using a natural object as a cosmic courier isn't alien, it's human. But what if we're on the receiving end? After the session, Birdie's friend revealed the target 13 Atlas, the interstellar object that wouldn't hit headlines for weeks. She had described something the world didn't yet know existed. But Birdie wasn't done. She conducted 2 more sessions diving deeper, and what she uncovered changed everything. It's broadcasting, she said. Not was broadcasting billions of years ago, but is broadcasting right now in pulses, deliberate rhythmic signals. When the podcast host mentioned that astronomer Avi Loeb had calculated 3D Atlas originated from the same region of the sky as the 1977 WOW signal, Birdie didn't flinch. That's super interesting, she said. It's very possible that's the WOW signal. Remote viewing isn't hard science. It's anomalous cognition, subjective and divisive, dismissed by skeptics, revered by believers, with the truth likely somewhere in the murky middle. But Birdie wasn't alone. Multiple independent remote viewing groups targeted 13 Atlas in the months following its discovery, and their findings aligned in haunting ways. Themes emerged: technology, deliberate placement, active broadcasting, and the presence of non-human intelligence. One group reported humanoid forms linked to the object. Another described graffiti marking signatures as if someone had claimed it. Several sensed the object was masked, evading full detection, as if it chose to remain elusive. Some reports were chillingly specific: special access extraction points, timetables, details that sounded less like mystic visions and more like classified briefings. Then came the darker threads, references to crop circles, advanced spherical craft hybrid warfare, and an invisible war. The phrase brain scanning technologies surfaced across multiple sessions, hinting at a capability to influence minds, perhaps even trigger mass hysteria or hallucinations. Does this prove 13 Atlas is more than a comet? No. These are impressions, not photographs or measurements. But their consistency across unconnected viewers, combined with their alignment with later scientific anomalies, is impossible to ignore. Consider Birdie's vision, a tiny ancient device buried in a comet. If true, what would we see? From a distance, it would mimic a comet ice dust, outgassing all the expected traits. But up close, anomalies would emerge: unusual chemical signatures, unexpected materials, behaviors that feel engineered rather than random. It might be denser than its size suggests, harboring something solid at its core that doesn't vaporize with the ice. And if you had the right instruments tuned to the right frequency at the right moment, you might detect a signal, a pulse, a pattern, something that shouldn't be there. Birdie perceived all this in August, before the scientific data rolled in, before telescopes detected impossible chemistry, before NASA's silence became deafening. She described a cosmic message in a bottle hurtling toward us. Now, as 13 Atlas slips behind the sun, hidden from every telescope until December, and as official images from the Mars flyby remain locked away, the object approaches perihelion on October 29th, its moment of maximum heat, maximum stress, what Avi Loeb called the point where confessions are elicited. If a thumb drive-sized piece of technology lies at its heart, this is when it will either reveal itself or vanish forever. And yet, one question lingers sharper than ever. Why, just as we were poised to get our clearest look, Did NASA furlough 15,000 employees? What did they see that were not being shown? As remote viewers and amateur astronomers alike piece together this cosmic puzzle, the silence from above grows louder and the truth feels tantalizingly close, yet just out of reach. Chapter 3. The Weight of NASA's Silence. October 3rd, 2025 was poised to be a landmark moment in human history, a day when we would gaze upon an interstellar visitor with unprecedented clarity. The Mars Reconnaissance Orbiter, its high-rise camera, primed to capture details 30 times sharper than Hubble's best, stood ready. The European Space Agency's Mars Express and EXNAN's Trace Gas Orbiter, bristling with advanced instruments, were locked on target. Every major space agency on Earth had prepared for months to seize this fleeting opportunity to study Shutdown Atlas as it passed just 29 million kilometers from Mars. And then, at the precise moment when humanity needed NASA most, the agency vanished. A staggering 15,000 employees, 83% of NASA's workforce, were furloughed, sent home during what should have been the most ambitious observation campaign in interstellar astronomy. The official explanation: a federal government shutdown, a budget impasse, nothing to do with Shutdown Atlas, just unfortunate timing. Those two words carry a heavy burden, attempting to dismiss the cosmic coincidence that the world's leading space agency went dark, just as an object exhibiting 7 statistical impossibilities sailed past our Martian outposts. Let's consider the odds. Shutdown Atlas was discovered in July 2025. The Mars flyby was meticulously planned for months. Scientists knew this was their one shot to capture high-resolution images before the object slipped behind the sun out of sight. NASA knew. ESA knew. Every spacefaring nation knew. Yet, in the critical final week before the closest approach, the US government ground to a halt. NASA's website froze. Press releases stopped. The army of scientists who should have been poring over data processing images and sharing discoveries was sidelined, leaving only a skeleton crew to maintain critical operations. But here's where it gets suspicious. The Perseverance rover's raw image feeds kept flowing. The Mars Reconnaissance Orbiter's cameras didn't stop rolling. The data was being collected, images were being captured, but none of it reached the public. On that same October 3rd, an amateur astronomer known as Dobsonian Power, a YouTuber armed with a solar telescope, posted an image that sent shockwaves through the online community. The caption was simple: "What on earth is it?" The image revealed something dark, angular, and distinctly uncomet-like, embedded in the expected position of Shutdown Atlas. Within hours, thousands had viewed it, demanding answers. If a backyard observer could capture this, what were the professional instruments capable of resolving car-sized features on Mars? Seeing NASA said nothing. ESA said nothing. The only glimpse we got came from Simeon Schmaus, the astrophotographer who stacked 20 Perseverance Mastcam Z images to reveal that now infamous faint smudge of light. But Simeon wasn't NASA. He was a private citizen sharing his findings on social media because official channels wouldn't. Then came a White House press briefing that shifted the narrative. Deputy Chief of Staff for Policy Stephen Miller was addressing the government shutdown when a reporter posed the question burning across the internet. Has the president been briefed about Shutdown Atlas? The room fell silent. Miller paused his words, measured, then deflected. The briefing moved on, but the moment was seismic A direct question about an interstellar object asked on camera in an official setting. It could no longer be dismissed as fringe chatter. The US government was being pressed for answers, and it chose silence. Meanwhile, astronomer Avi Loeb was relentless, appearing on Newsmax CBS podcasts, any platform that would listen. With surgical precision, he laid out the anomalies, a trajectory aligned with the ecliptic plane, 0.2% probability timing optimized for planetary encounters, 0.0% probability, and 7 characteristics that set Southie Atlas apart from anything ever observed. He kept circling back to one demand. We need the Mars orbiter data. The high-rise images could reveal the nucleus's diameter, resolve its structure, and answer the fundamental question, what is this thing? Yet those images remained locked away. On a podcast with Brian Keating-Loeb revealed that Representative Tim Burchett, a member of the House Committee on Oversight and Accountability, had joined him on Newsmax to discuss Third Atlas and the suspicious silence. A sitting congressman on national television questioning the lack of transparency. This was no longer the realm of conspiracy theorists. It was mainstream. The European Space Agency broke their silence with a terse statement, confirming that Mars Express and ExoMars Trace Gas Orbiter had successfully observed Third Atlas during the flyby window of October 1st, 7th. Their instruments, high-resolution stereo cameras, color and stereo surface imaging systems, and multiple spectrometers had collected data. Results would be published when ready, they said. No images, no preliminary findings, no hint of the excitement you'd expect from capturing the closest ever views of an interstellar object. Just a dry acknowledgement, followed by silence. China's Tianwen-1 mission, silent. The UAE's Hope Orbiter, silent. Every spacecraft at Mars had been watching, yet every space agency on Earth had gone mute. Compare this to 2I Borisov, the previous interstellar comet that passed through in 2019. Back then, images flooded out immediately. Scientists were electrified, press releases abundant, the astronomical community buzzing with excitement. It was exactly what you'd expect for a rare visitor from beyond our solar system, worthy of intense study and public celebration. 2I Borisov played by the rules, the right chemistry, the right tail, predictable outgassing. It was fascinating but familiar, never challenging our understanding or raising uncomfortable questions. 3. Atlas does all of that and more. As it vanished behind the sun, heading toward its October 29th perihelion, the silence grew heavier. Amateur astronomers shared their final grainy images. Scientists published carefully worded papers, avoiding speculation. And 15,000 NASA employees waited to return to work left to wonder what their essential colleagues had seen in those unreleased Mars orbiter images. The question hangs in the air as sharp and unyielding as the object itself, if Third Atlas is just a comet. Why is the world's greatest space agency holding its breath? Chapter 4. 7 Impossible Things. There is a principle in science called Occam's razor. When you have competing explanations, the simplest one is usually correct. One anomaly can be explained away. 2 might be coincidence. But when you stack 7 statistical impossibilities on top of each other, Occam's razor starts cutting in a different direction, straight toward something extraordinary. Something that defies our understanding of the cosmos. Let me walk you through what makes 3I Atlas unlike anything we have ever tracked through our solar system, a celestial enigma that whispers of origins beyond the stars. Anomaly. 1. The mass problem. When astronomers first calculated the size of 3I Atlas based on its brightness, they got a number that made no sense. A figure that shattered expectations. If all that light was just reflected sunlight, the object would have to be somewhere between 10 and 20 kilometers across. For context, Oumuamua was barely 100 mil. 2I Boris was less than 1 kilowatt. This thing appeared to be orders of magnitude larger, a behemoth streaking through the void. The statistical models that predict how many interstellar objects we should detect are very clear. Small objects are common. Large objects are exceedingly rare, like finding a diamond in a sea of pebbles. We should have found hundreds, maybe thousands of Oumuamua-ized visitors before stumbling across something the size of 3I Atlas. The probability was calculated at roughly 0.01% 1 in 10,000 dollars, a cosmic lottery ticket that no one expected to win. But then came the astrometric data. Over 4,000 measurements from 227 observatories between May and September painted a picture of unyielding precision. When scientists analyzed the object's trajectory and compared it to pure gravitational acceleration, they found something remarkable. Almost no deviation. Despite heavy outgassing, despite losing 150 kilo of material per second in explosive bursts, the object barely budged from its expected path, holding its course with ironclad resolve. That implies enormous mass. A nucleus so heavy that even constant jetting of gas and dust cannot push it off course like a mountain unmoved by a gale. The calculations suggested more than 33 billion tons a diameter, larger than 5 kilometers, making it not just bigger than the previous interstellar visitors, but roughly 1 million times more massive than Oumuamua. 1 million times. Think about that gap. It's like comparing a grain of sand to a boulder, a whisper to a thunderclap echoing across the heavens. Anomaly. 2. The sun would glow. Hubble captured the highest resolution image of 3I Atlas on July 21st, 2025, a snapshot that unveiled a defiance of the stars themselves. Scientists analyzing that image noticed something that had never been documented in any comet solar system or interstellar, a bizarre asymmetry that challenged the laws we thought immutable. The scattered light around the object extended roughly twice as far toward the sun as it did perpendicular or opposite to the sun, as if drawn inexorably toward the light rather than fleeing it. Comets have tails that point away from the sun because radiation pressure pushes dust particles outward. This is basic physics confirmed by thousands of observations over centuries, a dance as old as the solar system itself. 3 Atlas appeared to be violating that principle, rewriting the rules in mid-flight. The extension was not subtle. It was a 10:1 ratio, 10 times longer in the solar direction than sideways, a stark elongation that gripped the imagination. And this was observed edge on meaning. The true elongation was even more extreme when accounting for viewing geometry, a hidden depth that amplified the mystery. Avibe and Eric Kaito published a paper offering an explanation involving ice fragments that sublimate at different rates depending on which side of the object they are ejected, from a clever hypothesis born of desperation. The physics was sound, the math checked out, but it required a very specific set of conditions that had never been observed before in any other comet, a fragile alignment of factors, improbably perfect. A unique configuration that just happened to occur in an interstellar visitor already exhibiting multiple other anomalies, stacking improbability upon improbability, like cards in a house defying gravity. Anomaly 3. The industrial fingerprint. In late August and early September, the Very Large Telescope in Chile trained its UV's spectrograph on 3II Atlas and detected something that stopped scientists cold as spectral whisper from the forge of creation, or perhaps something more artificial. Nickel atoms in the gas plume. Lots of nickel rising exponentially as the object approached the sun, increasing by a power law of roughly 9 surging like a heartbeat, quickening in the heat. But here is the problem. They detected almost no iron. In nature, nickel and iron are born together in supernova explosions, cosmic siblings forged in the same stellar cataclysms. They occur in roughly fixed ratios, an unbreakable bond etched into the fabric of the universe. Every natural comet ever observed shows nickel and iron in similar abundances. 2. I. Borisov. The previous interstellar comet had normal nickel to iron ratios. Every solar system comet has normal ratios, a consistent signature across the void. 3I Atlas was producing nickel without iron, a purity that screamed of intervention. The only place we see that signature is in industrial production. Nickel alloys materials that have been deliberately refined and separated by intelligent hands. The scientists who published this data were careful in their wording. They called it extremely puzzling an understatement that masked their awe and unease. They noted that the temperature at the object's distance from the sun was far too low to vaporize the refractory minerals that contain these metals under normal conditions, a thermal barrier that deepened the riddle. They proposed some chemical pathways that might explain it, but you could feel the uncertainty in the prose, a hesitation that betrayed the limits of our knowledge. Anomaly. 4. Polarization from another world. When light scatters off particles, it becomes polarized. The degree and direction of polarization tells you about the size, shape, and composition of those particles, a subtle code written in waves. Comets have characteristic polarization signatures, fingerprints of their dusty veils. We have measured hundreds of them. The patterns are well understood, mapped like constellations in the night sky. 3E Atlas showed a polarization signature that does not exist in any catalog, a rogue pattern defying classification. 2.77% at a phase angle of around 7 degrees, an inversion angle of only 17 degrees. This combination had never been measured in any asteroid or comet solar system or interstellar, a solitary outlier in a sea of data. The closest match was not comets at all. It was trans-Neptunian objects and a specific centaur called Pholus icy bodies from the outer reaches of the solar system with very different compositions and histories than typical comets, ancient wanderers from the fringes, not fiery interlopers. A paper submitted to the astrophysical journal Letters concluded that 3I Atlas may represent a distinct type of comet expanding the diversity of known interstellar bodies, a polite way of admitting defeat. Distinct type is scientific language, for we have no category for this. A blank space on the map of the universe begging to be filled. Anomaly. 5. The ecliptic alignment. The solar system is basically flat. The planets orbit in a plane called the ecliptic, a cosmic disk spinning in harmony. Random objects from interstellar space derive from random directions, crossing that plane at random angles, chaotic intruders from the galactic wilderness. The probability of an interstellar visitor's orbit aligning within 5 degrees of the ecliptic is roughly 0.2%. 1 in 500, a needle thread precision in the haystack of infinity. 3 Atlas arrived aligned within 5 degrees, slipping into our plane like it belonged. Not only that, but it is moving retrograde, opposite to the direction planets orbit a counterflow that hinted at deliberate intent. This is the ideal trajectory if you wanted to survey multiple planets with minimum course corrections, a path optimized for observation, not accident. Anomaly 6. The planetary timing. 3 Atlas will pass close to 3 planets during its flyby. Venus at 0.65 astronomical units, Mars at 0.19, AU Jupiter at 0.36 AU, brushing past worlds like a silent scout charting the neighborhood. The probability of a random interstellar visitor arriving with timing that allows close approaches to 3 different planets is approximately 0.0005%. 1 in 20,000 odds that strain credulity to the breaking point. If you were designing a reconnaissance mission to our solar system, this is the trajectory you would choose: a masterful arc through the heart of our domain. Anomaly 7. The WOW signal coincidence. In 1977, the Big Ear radio telescope detected a signal so unusual that astronomer Jerry Amon wrote "wow" in the margins, a marginal note that became legend. It came from the constellation Sagittarius, lasted 72 seconds, and has never been detected again, despite decades of searching, a ghostly echo lost to time. When scientists traced 3I Atlas's trajectory backward through the galaxy, accounting for its speed and direction, they calculated where it would have been in 1977. The answer within 9 degrees of the WOW signal origin, a celestial convergence that chilled the spine. The probability of this alignment is roughly 0.6%, another layer in the tapestry of improbabilities. 7 anomalies, 7 statistical long shots, and we're being asked to believe they are all coincidence, mere flukes in the grand lottery of the stars. But as these impossibilities pile up, one can't help but wonder, what if this isn't chance, but a message from the depths? Chapter 5. October 29th. The Confession. As you read this, 3 Atlas is cloaked in shadow, hidden behind the sun, hurtling toward a crucible where the laws of physics strip away all pretense. Perihelion, its closest dance with our star, looms on October 29th, 2025, at roughly 144 astronomical units, just inside the orbit of Mars. At that moment, the sun transforms from a distant beacon into an unrelenting inferno, its radiance hammering the object with an intensity that defies imagination. Picture standing before an open blast furnace, the heat searing your skin. Now amplify that by a factor beyond human comprehension. Gigawatts of raw solar power pummeling the surface, a cosmic forge that demands truth. Avib, the scientist whose words carry the weight of insight, once said, "High-stress environments elicit confessions." He was speaking of interrogations, but the principle holds for the cosmos. When you subject ice to such heat, it can only be ice. Rock reveals itself as rock. And if something masquerades as a comet but harbors secrets, perihelion is where the mask burns away. 2 paths diverge at this fiery crossroads, each leading to a radically different truth. Scenario 1. 3 Atlas is what it seems, a comet, albeit one draped in mystery. Its massive size, bizarre chemistry, and statistical defiance all somehow woven into the natural tapestry of the universe. If so, October 29th will unleash a spectacle. The surface kissed by solar fury will awaken. Volatiles frozen for billions of years in the interstellar void will erupt under the sun's relentless gaze. Carbon dioxide will sublimate, water ice will vaporize, and dust will rise in towering plumes, painting the sky with chaos. We've seen this before comets at perihelion blaze into magnificence. Their tails stretch millions of kilometers, glowing with ethereal splendor. They brighten tenfold sometimes, fracturing under the strain, their fragments scattering like cosmic confetti. It's violent, chaotic, and breathtakingly beautiful. If 3 Atlas is natural, we'll witness this grandeur, a massive outburst of gas and dust, a proper comet's tail unfurling, not that strange sunward glow, but a radiant stream pushed back by the solar wind's unyielding force. If the object is as fragile as some suspect, if its 5-kilometer bulk is a loose lattice of ice rather than unyielding rock perihelion, could tear it apart entirely. We might watch in real time as an interstellar traveler shatters, offering a rare glimpse into the heart of a comet born in another star system. Such an event would be a scientific treasure, answering questions about comet formation, the chemistry of distant worlds, and the forces that hurl objects across the galaxy. Even if it means the destruction of 3 Atlas, it would be a gift to knowledge. But then, there's scenario 2. 3 Atlas is not natural. The anomalies, the nickel without iron, the backward tail, the eerie alignment with the ecliptic, and the wow signal's origin are not mere quirks, but threads of a larger design. In this scenario, perihelion isn't about sublimation. It's about awakening. Imagine you're an intelligence sending a probe across the stars. It must endure billions of years in the frigid, radiation-battered void, vulnerable to time's slow decay and the violence of cosmic impacts. Encasing it in ice is ingenious ice, is abundant, protective, a perfect disguise that blends into the galactic backdrop until the probe is ready to reveal itself. But when it nears the inner solar system, when it grazes the host star, it must awaken. It needs power, and there's only one source, the star itself. Perihelion, in this case, isn't a trial by fire, it's a charging station, a moment of activation. Lowe, in his meticulously crafted papers, laid out the possibilities with chilling precision. The object could execute a solar orbit maneuver, a technique our own spacecraft use, diving close to the sun to harness its gravity, accelerating and shifting trajectory with minimal fuel. It's the most efficient way to navigate the solar system, and perihelion is the perfect moment. Conveniently, 3 Atlas reaches this point while hidden from Earth's gaze, veiled behind the sun's blinding light. If it sought to change course undetected, this would be the moment, a cosmic sleight of hand. Or it could release something: miniature probes, small craft detaching to exploit the retrograde trajectory, slipping toward Mars, Earth, or Jupiter with effortless precision. The timing of its planetary alignments makes this almost too easy a choreography that feels less like chance and more like intent. Lowe was blunt about the stakes. If 3 Atlas maneuvers toward Earth when it emerges from the sun's shadow, the consequences could ripple beyond science. Financial markets could collapse not as hyperbole, but as a sober prediction of humanity grappling with the realization that we are not alone, and the visitor might not come in peace. But now we are blind. From late October to early December, every telescope on Earth, every space-based observatory is thwarted by the sun's glare. 3 Atlas is in a communication blackout, a perfect window for a craft that wishes to keep its next move secret. The European Space Agency has a plan. Between November 2nd and 25th, the Jupiter Icy Moons Explorer JUICE spacecraft en route to Jupiter will turn its instruments toward 3 Atlas. JUICE will catch the object just after perihelion, when its activity should peak, when whatever is destined to happen has already begun. JUICE wasn't built for comets. Its cameras and spectrometers are tuned for icy moons, for probing subsurface oceans and alien chemistry. But those same tools can scrutinize 3 Atlas. Positioned between Earth and the Sun, JUICE has a vantage point we lack a front row seat to the cosmic drama. If 3 Atlas unfurls a massive coma and tail, JUICE will see it. If it fragments, JUICE will capture the debris field, a mosaic of destruction. And if it does something unexpected, if it maneuvers, releases objects, or betrays any hint of artificial behavior, JUICE will record that too. The data won't come instantly. Space communication is slow, and JUICE is far from home. But by late November or early December, answers will arrive just as 3 Atlas re-emerges into Earth's view. December 19th marks its closest approach to our planet. 188 astronomical units, no threat, but near enough for every major observatory to lock on tracking its path with exquisite precision. That's when we'll know. If its orbit matches the gravitational models, we can exhale a strange but natural visitor passing through on its way back to the cosmic dark. But if the numbers don't add up, if the trajectory shows even the slightest deviation unexplained by outgassing or solar pressure, every assumption about our place in the universe will unravel. October 29th is the day 3 Atlas confesses its true nature. But we won't hear that confession until December. And by then, it may be too late to do anything but watch the next act unfold. Chapter 6. The Global Firestorm. While scientists wrestled with data and NASA held its tongue, a different force was gathering momentum, one that outpaced the measured pace of peer-reviewed papers. The internet was ablaze, a wildfire of speculation spreading faster than any fact could hope to contain. It began, as it often does, in the United States. TikTok videos of 3 Atlas, some real, most doctored, racked up millions of views, each frame fueling curiosity and dread. Reddit threads ballooned into sprawling debates, thousands of comments weaving fact and fiction into a chaotic tapestry. On X, the platform formerly known as Twitter, a war raged. Amateur astronomers shared legitimate observations only to be drowned out by influencers peddling wild claims for clout. But America was merely the spark. In India, the narrative morphed into something far more vivid. WhatsApp, the lifeblood of communication for millions, became a conduit for rumors that raced ahead of any fact-checker's reach. Messages in Hindi spread like wildfire, painting 3 Atlas as an alien ship cloaked in cosmic deception. Urgent voiceovers narrated videos claiming the object was shifting course, defying physics. Fake news screenshots with headlines crafted to terrify circulated endlessly. One viral forward insisted world governments were already in talks with whatever or whoever was aboard 3 Atlas. Another whispered of secret military mobilizations. A third, chillingly convincing, showcased an edited image stamped NASA classified, revealing a geometric structure where a comet should have been. None of it was true. All of it spread like a contagion. Hindi language YouTube channels erupted, some earnestly explaining interstellar objects, others plunging into speculation that blended astronomy with ancient astronaut myths and apocalyptic prophecies. The boundary between education and entertainment dissolved, leaving a feverish haze where truth and fantasy intertwined. Brazil mirrored this frenzy on Telegram and Facebook. UFO communities, already primed to see signs in the Amazon's night skies, seized on 3 Atlas with fervor. Here was no mere light in the sky, but a tangible interstellar visitor, its bizarre behavior even stumping scientists. Brazil's conspiracy ecosystem, a vibrant blend of indigenous lore, Catholic mysticism, and modern UFO mythology, transformed 3 Atlas into a kaleidoscope of meaning, a harbinger of doom, a vessel of benevolent beings, a weapon, a gift, a divine test. Facebook groups swelled with new members, their live streams stretching for hours as hosts read scientific papers aloud, then veered into theories far beyond the data. Comment sections became digital campfires where thousands gathered to share fears, hopes, and wild imaginings in equal measure. In the United Kingdom, with its storied history of crop circles and UFO inquiries, 3 Atlas was met with a blend of skepticism and intrigue. Tabloids tread a fine line, their headlines sensational yet carefully deniable. Massive comet could be alien tech scientists say. The scientists were often just Avibe quoted out of context, but the words did their work stoking curiosity and unease. Russia viewed the phenomenon through a geopolitical lens. State media mentioned 3 Atlas sparingly, always framing it as a puzzle exposing Western uncertainty. Some outlets hinted that American confusion was a pretext for bloated military budgets. Others suggested the US knew more than it let on, perhaps even tied to black budget programs making contact. Russian language forums buzzed with technical discussions, often impressively detailed, but laced with claims of secret space programs, recovered alien tech, and conspiracies stretching back to Soviet days. Then came the Michio Kaku incident. A screenshot surfaced, showing the renowned physicist in what seemed to be a TV interview, overlaid with text claiming he'd declared, 3 Atlas, a reconnaissance probe possibly hostile. The caption screamed, it might be an alien probe sent to Earth. The image was real. The context was not. Fact-checkers traced it to a Nation News interview from February 20th, 2025, months before 3 Atlas's discovery, where Kaku discussed an unrelated asteroid scenario. Someone had hijacked his words, slapped on false text, and set it loose. It didn't matter that it was fake. The post amassed over 290,000 views before platforms flagged it, and by then it had been screenshot and reshared into oblivion, each version harder to debunk. The account, Lord Bebo, never retracted. The damage was cemented. Thousands now believed a trusted scientist had confirmed 3 Atlas as alien technology. NASA tried to stem the tide. On September 30th, their official solar system account posted, Comet 3I Atlas poses no threat to Earth. It will remain hundreds of millions of kilometers away. This is a natural interstellar object, extremely rare and scientifically valuable, but not dangerous. The response was swift and cynical. If it's just a comet, why the silence? Explain the nickel without iron. Why the shutdown? NASA's lone statement stood no chance against the tidal wave of doubt and speculation. Al Jazeera's fact-checking arm, Sanad, published a meticulous investigation. They confirmed 3 Atlas's discovery by the Atlas telescope on July 1st, 2025, and its safe distance of 270 million kilometers at closest approach. They debunked the Kaku quote, the military rumors, the secret negotiations. It was solid journalism, but it swayed few. While Sanad checked facts, Avi Lowe was speaking in hushed tones at the United Nations, not in the General Assembly, but in private meetings with delegates in papers slipped to policy advisors, where the word existential carried chilling weight. Lowe presented his black swan scenario: low probability, high impact events demand preparation, especially when they seem impossible until they're not. A black swan, as Nassim Taleb described in Financial Crashes, is unthinkable until it happens, then inevitable in hindsight. Lowe applied it to interstellar visitors. We assume they're natural because that's all we've known. But what if that assumption crumbles? The hashtag, The Harbinger, began trending not in mainstream feeds, but in niche communities obsessed with 3 Atlas. The term, drawn from ancient texts, evoked messengers from the sky portents of change, judgment, or transformation. For some, it was literal end times theology mapped eerily onto an object defying explanation. For others, it was a metaphor for a new space age, humanity's awakening to a universe far less empty than we'd dreamed. Through the chaos, one name kept surfacing. Stefan Burns, the cosmologist Moneypenny had mentioned. Rumors swirled that Burns believed 3 Atlas was intelligent, even conscious, already communicating with Earth and other worlds. No paper, no interview, no direct quote confirmed this, just cryptic social media posts and second-hand claims. Yet the idea took root, fitting too perfectly into the mosaic of anomalies, silence, and unease. The world was no longer just watching the sky. It was holding its breath, waiting for a truth that felt just out of reach. Chapter 7. December's Verdict. Early December 2025. 3 Atlas will pierce the sun's blinding curtain, emerging from its fiery seclusion like a cosmic voyager breaking the surface after a perilous plunge. Astronomers will hunt for it in the constellation Virgo, a faint speck shimmering low on the pre-dawn horizon, its glow hovering at magnitude 12 or 13, too elusive for amateur scopes, but a blazing target for the world's most advanced observatories. From mountaintops to orbital platforms, every lens and sensor will lock onto this enigmatic wanderer, and the numbers it yields will weave a tale that could either anchor us to familiar physics or unravel the very fabric of our understanding. Orbital mechanics is humanity's finest blade, forged by Newton's laws and sharpened by Einstein's relativity. It allows us to chart an object's path across years, pinpointing its position to within a kilometer, factoring in the gravitational dance of planets, the gentle shove of sunlight's radiation pressure, and even the erratic push of outgassing as a comet sheds its ancient skin in fiery bursts. When 3 Atlas reappears, its coordinates will speak with brutal clarity. If it sits precisely where our equations predict, allowing for the expected wobble from outgassing's chaotic jets, it will signal that nothing extraordinary transpired during its hidden passage behind the sun. It endured the searing crucible of perihelion, weathered the solar storm, and continued along its preordained arc, destined to slip beyond the outer solar system and vanish into the interstellar abyss, a fleeting guest from another star. But if it's off, if its trajectory deviates in ways no known force can account for, every study, every model, every paper written about 3 Atlas will demand a seismic revision. Celestial objects don't rewrite their paths without cause. Something must act upon them, a force, a mechanism, an intent, And the implications of such a shift would ripple through science philosophy and even the collective psyche of humanity. A single unexplained degree of arc could become the most significant data point in modern astronomy, a crack in the foundation of what we believe about the cosmos. The Vera Rubin Observatory will stand as our vanguard in this moment of truth. Newly operational, this telescope is a marvel, a revolution in how we scan the heavens. Where older surveys catalogued 20,000 asteroids annually, Rubin's wide-eyed gaze uncovered 2,140 in its first 10 hours, a staggering testament to its power. Its ability to map the sky with unprecedented depth and speed promises to transform our hunt for interstellar visitors. What was once a trickle of discoveries, one every few years, could swell into a flood with dozens of objects like 3 Atlas detected annually. Each will be scrutinized with the hard-earned lessons of this strange traveler, the chemical oddities like nickel without iron, the polarization signatures that defy catalogs, the orbital alignments that flirt with the impossible. If 3 Atlas is an anomaly, Rubin will seek its kin scouring the heavens for others that share its peculiarities. If it heralds a new category of cosmic objects, Rubin will map their family tree or confirm that 3 Atlas stands alone, a solitary enigma in an infinite sea. Yet, December is not merely about orbits and future discoveries. It's about questions that have festered since July, gnawing at the edges of our curiosity and patience. What did the Mars orbiters capture in their lenses? By December, the government shutdown will be a distant memory. NASA's teams back at full strength, their servers humming with activity. The high-resolution images from October 3rd snapped when 3 Atlas passed. Just 29 million kilometers from Mars's orbiting cameras will have been processed, analyzed, and either quietly filed away or prepared for a world-altering release. At that distance, a 5-kilometer object should reveal its form even through the haze of a coma. Not the intricate details of a close-up, but the broad strokes of its silhouette. Is it a sphere, an elongated cigar, an irregular shard? Do patches of varying brightness hint at a patchwork of materials, ice rock, or something stranger? Does it echo the rugged pitted nuclei of comets like 67P or Halley? Or does it bear a form unlike anything we've photographed in our solar system? The silence surrounding these images is deafening. Science thrives on the rush to publish, the fierce competition to claim first dibs on groundbreaking data. That multiple space agencies, NASA, ESA, and others, captured 3 Atlas at Mars and have yet to release detailed imagery raises questions that grow louder with each passing day. Is this an unprecedented act of global coordination, a collective decision to withhold findings? Or did those images reveal something so profound, so unsettling, that it demands careful deliberation before facing public scrutiny? December will force this silence to break. Either the images will emerge painting 3 Atlas as an unusual but natural comet, or their continued absence will become an answer in itself, a void that speaks louder than any press release. Radio astronomers, too, will be listening with bated breath. The shadow of the 1977 WOW signal looms large, its eerie alignment with 3 Atlas's trajectory, either a cosmic coincidence or a clue to something greater. If this object was the source of that fleeting, unexplained burst, and if it still has the capacity to transmit, December offers a narrow window to hear it. Radio telescopes worldwide have been quietly trained on the region where 3 Atlas will appear. not with the fanfare of SETI's public campaigns, but with the steady, meticulous vigilance of scientists who know the stakes. Any signal, a pulse, a pattern, a whisper in the radio spectrum tied to the object's position would rewrite history. The hydrogen line at 1421st is the frequency to watch a universal channel where the WOW signal flared and where any civilization seeking to be heard would broadcast. It's the cosmic equivalent of a beacon tuned to the spectral hum of hydrogen, the universe's most abundant element, a frequency that transcends stellar boundaries. If 3 Atlas has a message, this is where it will speak. December 19th marks the moment of truth. 3 Atlas's closest approach to Earth at 188 astronomical units, roughly 270 million kilometers, about 1.5 times the Earth-Sun distance. It poses no danger, but it's near enough for parallax to become a powerful tool. As Earth swings through its orbit, our shifting perspective creates a subtle displacement in 3 Atlas's apparent position. By measuring this parallax with exquisite precision, observatories can triangulate its exact distance and velocity, anchoring its trajectory in 3-dimensional space. Any deviation from the expected values, any hint of an unaccounted-for shift, will stand out like a flare in the dark. Observatories across the globe, from the icy peaks of Mauna Kea to the arid heights of Chile's Atacama Desert, will synchronize their efforts, spanning northern and southern hemispheres, every longitude ensuring round-the-clock coverage. Amateur astronomers, armed with increasingly sophisticated equipment, will join the professionals contributing data to a global mosaic. This will be the most exhaustively documented observation of any solar system object in history. A collective act of scrutiny unmatched in its intensity. Somewhere in this deluge of data positions, spectra images, radio signals, lies the verdict: confirmation or contradiction. Confirmation would mean 3 Atlas, for all its strangeness, is a natural object, an interstellar emissary shaped by the alien conditions of a distant star system, but governed by the same physics that binds our comets. Its anomalies, nickel without iron, sunward glow, ecliptic alignment, would be rare, but explainable quirks of a universe that delights in diversity. Contradiction, however, would mean something else entirely: a trajectory that defies gravity, a chemical signature that mocks nature, a behavior that cannot be reconciled with the laws we know. A single data point could break the model, forcing us to confront the possibility we've danced around for months, that 3 Atlas is not a product of chance, but of design. By late December, 3 Atlas will begin to fade its light dimming as it recedes from the Sun, drifting into the constellation Leo. By March 2026, it will graze Jupiter's orbit, a final farewell to the inner solar system before plunging toward the heliopause and the boundless dark of interstellar space. One way or another, December will deliver answers, not the full story, but enough to know whether we're witnessing the greatest comet spectacle of our generation, or the most profound upheaval in human understanding since Galileo turned his telescope skyward and dethroned Earth as the universe's center. The observatories are primed, their mirrors polished, their sensors calibrated. The equations are ready, etched in code and tested against centuries of observation. The world holds its breath, eyes fixed on the heavens. Now we wait for 3 Atlas to step from the Sun's shadow and declare what it truly is: a comet, a curiosity, or a challenge. to everything we thought we knew. Chapter 8. The Scientific Impossibilities. Let me pull you into the heart of the science that's robbing astronomers of sleep. Not the swirling rumors or fevered theories, but the raw, unyielding measurements that defy logic no matter how many times they're crunched. These are the numbers, the data points, the stubborn facts that refuse to fit within the boundaries of known physics, each one a whisper of something vast and unsettling. Let's start with the WOW signal, a ghost from 1977 that still haunts the edges of astronomy. On August 15, 1977, the Big Air radio telescope at Ohio State University, sweeping the sky in a routine SETI search, caught something impossible. A narrowband signal at 1420.4 MHz, the exact frequency where an artificial transmission would shine. The hydrogen line, a cosmic dial tone shared by any civilization seeking to be heard. It lasted precisely 72 seconds, the time it took Earth's rotation to carry the telescope's beam across a stationary source. The signal's strength was staggering 30 times louder than the cosmic background hum. On the printout, intensity values climbed from routine 1s and 2s to 5s, 6s, peaking at U, the system's highest alphanumeric marker, before it ran out of symbols. Astronomer Jerry Ehrman, stunned by the climb, scrawled one word in red ink. Wow. For years, decades, they searched for it again. Big Ear turned its gaze back to that patch of sky in Sagittarius hundreds of times. Other observatories joined the hunt, their dishes straining for a repeat. Nothing. Silence. The signal became astronomy's most enduring enigma, evidence of nothing, proof of nothing yet impossible to dismiss. Now trace 3 Atlas's path backward through the galaxy. With its velocity clocked at 60 km by chess calculations, place it in 1977 at roughly 600 astronomical units from Earth, 90 billion kilometers, 600 times the Earth-Sun distance. To produce a signal as strong as the WOW signal at that range, a transmitter would need to pump out between 0.5 and 2 gigawatts of power, focused into a beam so tight it could pierce 90 billion kilometers and still scream 30 times above the noise. That's not a battery. That's not a generator. That's a nuclear reactor's worth of energy, a feat no comet could achieve. Comets don't generate gigawatts. They don't emit coherent radio waves. They don't broadcast at the precise frequency that serves as a universal handshake for technological civilizations. But a probe designed to announce its presence before entering a star system might. One powerful pulse to say, "I'm here," then silence to cloak its approach until the moment is right. The alignment of 3 Atlas's 1977 position with the WOW signal's origin within 9 degrees is a statistical longshot, a 0.6% probability that begs the question, coincidence or calculation? Now shift to the chemistry, the data from the very large telescope that stopped scientists cold. Nickel without iron. In nature, these elements are cosmic twins forged in the crucible of a supernova's death throes. Nickel 56 decays into iron 56, born together in the same nuclear fires, locked in minerals that drift through space as an inseparable pair. Every meteorite, every asteroid, every comet we've studied carries both their ratios, varying slightly but always present together. 2I Borisov, the previous interstellar comet, showed a normal nickel-to-iron balance. Solar system comets follow suit. No natural process at the temperatures. 3 Atlas experiences far too low to vaporize. Refractory minerals can separate these elements. Yet 3 Atlas's gas plume is rich in nickel, nearly devoid of iron. a signature that screams of artificial refinement. On Earth, we strip iron from nickel daily to craft high-purity alloys for electronics, aerospace, and precision engineering. It's a hallmark of industrial processes, a chemical fingerprint of intent. The VLT team exhausted every natural explanation: exotic chemical pathways in the ice, hypothetical minerals from unseen environments, dust grain physics we haven't mastered. Each hypothesis crashed against the same wall: the temperature is too low, the conditions wrong, and the nickel output isn't static, it surges as 3 Atlas nears the sun, climbing exponentially by a power law of roughly 9. For every 10% closer it gets, the nickel production soars, a process that feels less like random outgassing and more like a system powering up, feeding on solar energy. Then there's the tail, the anomaly that spits in the face of planetary science's simplest truths. Solar radiation pressure is relentless. Photons slam into dust particles, imparting a tiny but unyielding push that overcomes a comet's feeble gravity, driving its tail away from the sun. Every comet ever photographed obeys this rule, their tails streaming like cosmic pennants in the solar wind. 3 Atlas defies it. Its scattered light, captured in Hubble's crystal-clear image on July 21, 2025, extends twice as far toward the sun as a 10:1 ratio that grows even starker when corrected for viewing geometry. Enhancement of the data only sharpens the impossibility. There's more material sunward than anti-sunward, a violation of physics as fundamental as gravity itself. Avibe and Eric Cato offered a model: large ice fragments ejected from the sun-facing side, surviving longer because of their size, creating an extended snow line toward the sun. The math holds if you accept a razor-thin set of conditions. The fragments must be precisely sized, ejected at exact velocities, with evaporation rates perfectly tuned to resist radiation pressure while scattering light efficiently. It's possible in the same way it's possible to flip a coin 50 times and land heads every time. Physics allows it, but the odds scream of a weighted coin. This pattern repeats across every anomaly. The mass, 33 billion tons, can be explained if 3 Atlas is denser than any comet we've seen. The ecliptic alignment, a 0.2% chance, can be a statistical fluke. The polarization signature, unmatched in any catalog, can be attributed to an unprecedented dust distribution. Each explanation holds in isolation, but together they form a tower of improbabilities, each layer requiring its own special pleading. 7 anomalies, 7 statistical impossibilities, all converging on a single object. At what point does the simplest explanation shift from natural chance to deliberate design? That question gnaws at scientists as 3 Atlas hides behind the sun, its silence as provocative as its presence. But the cosmos wasn't done with surprises. On October 1st, 2025, something else slipped through our defenses. Asteroid 2025 TF, a rock the size of a compact car, screamed past Earth at 20.9 km/s, 13,000 downloads per mph, passing just 499 kilometers above Antarctica, closer than the International Space Station's orbit. We didn't see it coming. The Catalina Sky Survey's BOK telescope in Arizona spotted it at 2:35 a.m. Eastern Time, 6 hours and 36 minutes after its closest approach. It wasn't tracked. It was glimpsed in our rearview mirror, already racing away. This was no planet killer, but its size and speed could have unleashed kilotons of explosive force in Earth's atmosphere, enough to devastate a city. And we had no warning. This wasn't a failure of skill, but of physics. Small asteroids, dark and fast, are nearly invisible until they're upon us. Our systems excel at tracking city killers larger than 150 meters, but objects like 2025 TF in the 1 to 10 meter range number in the millions slipping through our net like shadows. Its orbit calculated after the fact is a loose sketch, a 2.06-year path, tilted 9.12 to the ecliptic stretching from 0.676 to 2.56 astronomical units. With only a one-day observation arc, its future is a blur, potentially harmless, potentially a threat decades hence. The Tunguska event of 1908, which flattened 830 square miles of Siberian forest, was caused by a 30 to 50 meter object. 2025 TF is smaller, but not by enough to dismiss. Meanwhile, on Mars rovers, uncovered leopard spots, chemical patterns, frozen in rock, the clearest hint yet of ancient microbial life. Congressional hearings revealed footage of a military missile striking an unidentified object off Yemen's coast in 2025. The object shrugging off the impact and flying on. The sun entering a last gasp phase promises auroras brighter than any in decades. 3 comets, glowing green, race toward us, one potentially visible to the naked eye soon. NASA, furloughing 15,000 employees, competes with China for lunar dominance while a private company prepares the most powerful rocket ever built for a critical test. This is October 2025, not science fiction, but a world where the skies pulse with mystery. These events, each extraordinary, collide with 3 Atlas's anomalies, forming a mosaic of unease. The question isn't just what 3 Atlas is, but what it means in a universe suddenly far busier, far stranger than we ever imagined. Chapter 10. The Mars Breakthrough. Ancient life's smoking gun. For over a year, a single rock on Mars has haunted the dreams of scientists, not for its size or composition, but for the story etched into its surface, a story that whispers of life in a place where none should exist. On September 10th, 2025, NASA dropped a bombshell that sent shockwaves through the scientific community and ignited imaginations worldwide. The Perseverance rover's discovery of potential biosignatures in a sample dubbed Sapphire Canyon has withstood the fiercest scrutiny science can muster. Peer-reviewed and published in the prestigious journal Nature. Acting NASA Administrator Shah Duffy didn't mince words. This very well could be the clearest sign of life we've ever found on Mars. To understand why this moment feels like a turning point in human history, let's step back to the day it all began. On July 24, 2024, Perseverance's drill bit into an arrowhead-shaped rock nicknamed Chayava Falls, nestled in the Jezero crater, a site chosen for its ancient history as a lakebed fed by rivers billions of years ago. As the rover's instruments scanned the rock, they revealed something extraordinary, patterns dubbed leopard spots, small circular features with pale centers ringed by darker edges. These weren't mere geological curiosities. They were chemical signatures that on Earth would scream of microbial life. The spots harbored vivianite and greigite, 2 minerals forged in low-temperature, water-rich environments. Vivianite, a hydrated iron phosphate, often forms near decaying organic matter in sediments. Greigite and iron sulfide is a byproduct of certain microbes' metabolic processes. Finding these minerals alongside organic carbon creates what geologists call a compelling potential biosignature, a tantalizing clue that demands a closer look. The significance of Chayava Falls deepens when you consider its location. The rock lies within the Bright Angel Formation, a geological tapestry along the margins of Neretva Vallis, a quarter-mile-wide river valley that once funneled water into Jezero crater over 3 billion years ago. The mudstones and layered sediments of Bright Angel paint a vivid picture of a dynamic world, fast-flowing rivers, carving channels, giving way to tranquil lakes where sediments settled in stillness. This is precisely the kind of environment where microbial life thrives on Earth, wet, rich in nutrients, and stable enough for life to take hold. What stunned scientists was the age of these rocks. Bright Angel represents some of the youngest sedimentary formations Perseverance has explored, challenging the assumption that signs of life would be confined to Mars's oldest, most habitable eras. This discovery suggests Mars may have remained a haven for life far longer than we thought, or that life clung tenaciously to existence as the planet dried and cooled. Let's be clear, a potential biosignature is not proof of life. It's a clue, a shadow of possibility that demands rigorous investigation. As mission scientist Katie Stack Morgan emphasized, astrobiological claims, especially those hinting at extraterrestrial life, require extraordinary evidence. The Nature publication was the culmination of a year-long gauntlet of peer review, with independent scientists dissecting Perseverance's data for any non-biological explanation. Could geological processes mimic these patterns, volcanic activity, chemical weathering, or abiotic reactions might produce similar minerals, but none fit the evidence as neatly as the biological hypothesis. The leopard spots combination of organic carbon vivianite and greigite all tightly clustered mirrors patterns on Earth, where microbes consume organic compounds and leave mineral waste in their wake. Perseverance's instruments were key to this discovery. Sherlock scanning, habitable environments with Raman and luminescence for organics and chemicals, detected a strong spectral signature called the G-band, a hallmark of organic carbon. Pixel planetary instrument for X-ray lithochemistry mapped the rock's chemical elements with microscopic precision, revealing that the organic matter and redox-sensitive minerals weren't just present. They were co-located in the leopard spots, intertwined in a way that suggests a direct connection. On Earth, this pattern is routine. In microbial ecosystems, bacteria metabolize organic compounds, excreting minerals that precipitate exactly where the microbes live, forming distinctive structures. Chayava Falls' spots are eerily similar to those found in Earth's ancient rocks, where microbial activity is a known culprit. But there's a catch, a monumental one. Confirming a biological origin requires bringing the Sapphire Canyon sample back to Earth, where laboratories armed with isotopic analyzers, electron microscopes, and molecular probes can dissect it in ways no rover can. This is where the Mars Sample Return (MSR) mission enters the story, a joint NASA-ESA effort designed to retrieve Perseverance's carefully cached samples and deliver them to Earth's labs. But MSR is in crisis. Budget overruns and schedule delays have pushed costs into the billions. And President Trump's proposed 2026 budget threatens to axe the program, entirely slashing its funding to zero. During the September press conference, Duffy framed this not as abandonment, but as a pivot to a leaner, faster alternative. Yet the clock is ticking. China's own Mars Sample Return mission, slated for a possible 2028 launch, could beat the US to the punch, bringing Martian material to Earth first, and potentially claiming the historic discovery of extraterrestrial life. The geopolitical stakes are immense. The Sapphire Canyon sample, sealed in a titanium tube on Mars's surface, may hold the most profound scientific find in history, frozen evidence that could redefine life's place in the cosmos. But now, it waits in the Martian dust, a silent testament to a question we've asked for centuries. Are we alone? But the story doesn't end on Mars. Closer to home, another mystery unfolded on October 1st, 2025, when asteroid 2225 TF, a rock the size of a car, slipped past Earth at 419 kilometers closer than the International Space Station's orbit, traveling at 13,000 kph. Detected only after its closest approach by the Catalina Sky Survey, it exposed the limits of our planetary defense. Small, dark and fast, such objects are nearly invisible until they're upon us, and millions more lurk in the void. Meanwhile, congressional hearings revealed footage of a military missile striking an unidentified object off Yemen's coast, an object that didn't explode but kept flying. The sun entering a volatile last gasp phase promises auroras brighter than any in decades. 3 green glowing comets race toward us, one potentially naked eye visible soon. NASA, grappling with furloughs, races China to the moon, while a private company readies the most powerful rocket ever built. These events, each a headline in its own right, collide with 3 Atlas's anomalies: its nickel without iron, its sunward tail, its eerie alignment with the wow signal. Together, they paint a picture of a universe alive with possibility, danger, and questions we're only beginning to grasp. The Sapphire Canyon sample and the 3 Atlas may be pieces of the same puzzle, hinting at a cosmos where life or something more has been waiting for us to notice. Chapter 11. UFO Mystery Deepens Congress, Unveils Shocking Footage. On September the 9th, 2025, in the hallowed halls of the U.S. Capitol, Congressman Eric Burleson from Missouri strode into a House Oversight Committee hearing and unleashed a clip that shattered the veil of secrecy surrounding one of the most perplexing enigmas of our time. The video, captured on October 30th, 2024, depicted a luminous spherical orb slicing through the inky void against a churning sea, its path unyielding and unnervingly precise. Then, from the edge of the frame, a Hellfire missile hurtled in a precision-guided harbinger of destruction, designed to obliterate drones, vehicles, and threats with ruthless efficiency. What followed defied the ironclad laws of ballistics and engineering that generations of military minds have etched into doctrine. The missile connected squarely, a direct hit that should have vaporized the intruder in a fireball of shrapnel and flame. But the orb, it didn't erupt in a cataclysmic blaze. It didn't splinter into harmless fragments. It didn't even falter, as if the laws of momentum and explosive force were mere suggestions it deigned to ignore. Instead, the Hellfire appeared to glance off like a pebble, skipping across a frozen pond, veering harmlessly away on its own defiant arc, while the orb pressed on serene and unscathed, vanishing into the horizon as if mocking the futility of human weaponry. That's the Hellfire missile smacking into that UFO and just bouncing right off. Burleson declared, his voice laced with a mix of awe and frustration as the grainy footage looped for the stunned committee. And it kept going. He let the silence hang heavy with implication before delivering the gut punch. I'm not going to speculate what it is. But the question is, why are we being blocked from this information consistently? The footage hailed from an MQ-9 Reaper drone patrolling the volatile waters off Yemen's coast, a theater of shadows where U.S. Navy vessels and aircraft stood sentinel against a barrage of Houthi-launched missiles and drones threatening commercial shipping lanes. In that cauldron of conflict, American forces had honed a deadly rhythm: identify, engage, neutralize. Threats dissolved under the Reaper's watchful eye. But this orb, it danced to a different rhythm entirely. No erratic drone wobble, no telltale missile exhaust plume. It glided with an elegance that whispered of propulsion beyond our ken. And when the hellfire struck, its indifference to the assault wasn't just anomalous. It was a slap to the face of everything we assume about vulnerability and velocity. When pressed for authentication or context, the Department of Defense retreated behind a wall of evasion. A defense official murmured to reporters, "We do not have anything to provide on this." A spokesperson echoed the stone wall, "I have nothing for you." The silence wasn't golden. It was a thunderclap amplifying the footage's eerie resonance and fueling a firestorm of conjecture. If this was a glitch, a misfire, or classified tech from a rival power, why the blackout in a chamber built for accountability? The DoD's reticence only deepened the chasm between what the public is told and what shadows lurk in the classified vaults. Yet the Yemen clip was merely the opening salvo in a barrage of revelations that afternoon. Military veterans, their faces etched with the weight of oaths sworn and secrets buried, took the stand under the unblinking gaze of sworn testimony. They weren't wide-eyed enthusiasts chasing lights in the sky. These were guardians of the realm, pilots, analysts, operators with credentials forged in the crucible of service. Air Force veteran Dylan Borland, a geospatial intelligence specialist, recounted a chilling interlude from 2012. During a midnight shift at Langley Air Force Base in Virginia, he stepped out for a smoke, the humid night air thick with the hum of routine. Above him, defying the velvet sky, hovered a massive triangular craft, silent as a spectre, motionless as if anchored to the ether. For agonizing minutes, it loomed a monolithic intruder over one of America's most fortified installations. Then, with a surge that blurred the line between acceleration and teleportation, it rocketed skyward to commercial jet altitudes and streaked away at velocities that beggared belief. Borland didn't hesitate. He filed the report through ironclad channels, his duty, as clear as the stars it eclipsed. But in 2023, when ARO, the Pentagon's all-domain anomaly resolution office, summoned him for debrief, the encounter curdled into nightmare. Dismissed as delusion or misperception, his account was shelved. Worse retaliation slithered in whispers of manipulated security clearances, blacklisting from federal intelligence gigs, a career torpedoed not by incompetence but by candor. The system doesn't just ignore these encounters. Borland testified, his voice steady but laced with the scars of betrayal. It punishes those who dare to speak. His words hung like an indictment, painting a bureaucracy more adept at silencing than seeking truth. A machine that chews up whistleblowers and spits out pariahs, ensuring the skies remain the domain of the unexplained. The hearing transcended personal sagas, morphing into a clarion call for reckoning. Representative Anna Paulina Luna, the task force chairwoman whose resolve burns with the fire of a crusader, set the tone from the gavel's fall. For too long, the issue of unidentified anomalous phenomena, commonly known as UAPs, has been shrouded in secrecy stigma, and in some cases, outright dismissal. This is about national security government accountability and the American people's right to the truth. Her words weren't rhetoric. They were a gauntlet thrown at the feet of an establishment long accustomed to opacity. What elevates this spectacle above the dusty annals of UFO lore is its unassailable pedigree. These aren't blurry backyard snapshots or fevered tales from the fringes. They're sensor feeds from multi-million-dollar platforms captured amid the high-stakes ballet of combat operations. The witnesses, not theorists, cloaked in tinfoil, but warriors with unblemished dossiers, top-secret clearances, and the scars of real-world missions. The pushback, not from clandestine cults, but from the very Pentagon offices tasked with illumination, ARO, the self-proclaimed beacon of rigorous scientific framework and data-driven approach. Yet, ARO insists no verifiable extraterrestrial fingerprints, no tech from the stars. Critics howl at the sleight of hand. Cases like Yemen's orb get waved away with explanations that strain credulity, like the 2015 Go Fast video, dismissed as a balloon, beguiled by parallax and ocean waves, despite pilots' eyewitness fury that no camera trickery captured the raw terror of objects outpacing FA-18s. For the Yemen Enigma skeptics, float balloons adrift in stratospheric winds, sunlight glinting to feign motion, the missile a near miss masked by angles. But former Pentagon intelligence chief Luis Elizondo, testifying with the gravitas of one who's peered into the abyss, dismantled the facade. "We've never seen a Hellfire missile hit a target and bounce off," he thundered. When a Hellfire lands a kinetic strike on something solid, there's usually not much left. It's very, very destructive. In the video, the missile either redirects or skims away, leaving the orb to glide on, perhaps trailing faint debris like an afterthought. Elizondo's rebuke wasn't speculation. It was a veteran's verdict on the gulf between official narrative and battlefield reality. So where does that leave us? Teetering on a razor's edge between paradigms. Either the US military brushed against a craft wielding physics-bending resilience technology that laughs at our deadliest ordnance, or a prosaic truth festers in classified silos withheld for motives as opaque as the orb itself. Neither path soothes the soul. And this isn't a lone flare in the night. The National UFO Reporting Center tallied over 2,000 UAP sightings in the first half of 2025, alone a surge that outpaces prior years like a gathering storm. The Pentagon through ARO logged more than 750 fresh reports from May 2023 to June 2024, with unexplained cases lingering like ghosts. 21 incidents defying resolution, from video anomalies to eyewitness clashes near sensitive sites. Whatever prowls our skies is escalating, etching itself into the collective consciousness with insistent frequency, as governments wrestle with these atmospheric phantoms, objects that flit through restricted airspace like uninvited specters. Another celestial drama simmers overhead, as reliable as the dawn, yet no less awe-inspiring. Driven by the sun, our life-giving furnace, a cascade of solar fury, is set to ignite the poles in displays of light that could rival the auroras of myth. A reminder that even in our mastery of the stars, the cosmos holds spectacles that humble us all. Chapter 12. Solar Fury, the sun's last gasp. In October 2024, amidst the clamor of earthly concerns, scientists issued a proclamation that should have seized the world's attention, but slipped quietly beneath the radar of daily life. The sun, our celestial anchor, has reached solar maximum, the zenith of its 11-year activity cycle, a cosmic crescendo that marks not an end, but the prelude to a spectacle of unimaginable grandeur. For most, the term solar maximum sounds like an esoteric footnote, a tidbit for astronomers to ponder in their ivory towers. But what's unfolding on our star right now is no dry academic exercise. It's a primal force, a stellar drama poised to reshape our skies and challenge our technology for years to come. The sun is entering its last gasp, a phase where its ferocity doesn't wane, but burns brighter, fiercer, like a firework, saving its most dazzling burst for the finale. This is not the end of the show. It's the grandest act yet, and its effects could illuminate our world literally and figuratively through 2027 and beyond. To grasp the magnitude of this moment, we must first unravel what solar maximum means and why its aftermath promises to outshine the peak itself. Solar physicist Dr. Paul Brekke of the Norwegian Space Agency distilled it with crystalline clarity. It's good news for aurora chasers as peak auroral activity occurs a few years after solar maximum. Thus, we should have several years still with very high aurora activity. Let that settle in. The sun's most dramatic displays are not behind us. They're gathering strength, poised to paint the heavens with curtains of light that could rival the myths of ancient gods. To understand why we need to dive into the machinery of our star and the delicate dance it performs with Earth. At solar maximum, the sun's surface churns with chaos. Sunspots, dark turbulent regions of intense magnetic activity, proliferate their tangled field lines, twisting like cosmic knots under unimaginable stress. When these lines snap and reconnect, they unleash cataclysmic bursts of energy, solar flares, blinding flashes of radiation, and coronal mass ejections. CMEs, titanic eruptions that hurl billions of tons of charged plasma into space at speeds exceeding 1,000,000 miles per hour. When these plasma clouds collide with Earth's magnetic field, they ignite geomagnetic storms, funneling charged particles toward the poles. There, the particles slam into atmospheric atoms, sparking the shimmering veils of auroras, green, pink, and purple ribbons that dance across the night sky, a celestial ballet born of stellar violence. But the story takes a twist after solar maximum. As the cycle declines, the sun's explosive outbursts, flares, and CMEs begin to wane in frequency. You'd expect this to dim the auroral show, but the opposite holds true. In the declining phase, vast coronal holes emerge, dark, cavernous regions in the sun's atmosphere, where magnetic field lines stretch open into space like breaches in a fortress wall. These holes unleash relentless streams of high-speed solar wind torrents of charged particles that can persist for weeks or months, battering Earth's magnetic shield with sustained ferocity. Unlike the sudden explosive impact of a CME, these solar winds deliver a prolonged assault, triggering geomagnetic storms as potent as their flashier counterparts. Solar physicist Dr. Shay Scoff put it succinctly, "During the declining phase, we actually have more geomagnetic storms. The sun's eruption activity slows, but with coronal holes forming and lingering eruptions, you get more frequent and sometimes more intense auroral displays. We're already witnessing this cosmic choreography. In early October 2025, Earth endured 5 consecutive days of geomagnetic turbulence, driven by a solar wind stream roaring from a coronal hole at 768 km/s before easing to 608 km/s. Even at those calmer speeds, the wind sparked G1 minor geomagnetic storms, sending auroras rippling across northern latitudes, visible as far south as New York on some nights. Photographers in Iceland, Norway, Canada, and the northern US captured breathtaking vistas, emerald waves laced with pink and purple, undulating like liquid light against the starry void. This was merely a prelude. An M1.5 class solar flare in early October launched a modest CME, expected to graze Earth around October 8th, potentially igniting another round of auroral fireworks. Scientists forecast that solar cycle 25, now in its waning phase, will sustain this heightened geomagnetic activity well into 2027, driven by the interplay of lingering eruptions and persistent coronal holes. Earth's own rhythm amplifies this drama. We're in the equinox season, a time when our planet's magnetic field tilts at an angle that leaves it uniquely vulnerable to solar assaults. During equinoxes, the alignment of Earth's magnetic axis with the incoming solar wind opens a wider door for charged particles to breach our defenses, fueling stronger and more frequent auroras. It's as if the cosmos has conspired to make this moment a spectacle for the ages. The implications of this solar fury extend far beyond beauty. Geomagnetic storms are silent saboteurs capable of disrupting radio signals, skewing GPS accuracy, nudging satellites out of their orbits, and in extreme cases, crippling power grids. The Great Geomagnetic Storm of March 1989, triggered by a monstrous CME, plunged Quebec into darkness for 9 hours, frying transformers and tripping breakers as millions shivered in the cold. That storm hit G5 extreme on the geomagnetic storm scale, a rare beast. The storms of October 2025 have hovered between G1 and G3 minor to moderate, but even these can vex satellite operators and pilots, navigating polar routes where radiation risks climb. The KP index, which measures geomagnetic activity from 0 to 9, danced between 3 and 5 in early October, with spikes into storm territory. Forecasters predict this pattern will persist unsettled conditions, punctuated by bursts of stronger storms for months to come. For those of us tethered to the ground, the sun's last gasp offers a gift auroras that could be among the most spectacular in decades. If you live above 50 degrees in latitude, think Alaska, Scandinavia, or southern New Zealand, you'll have front row seats to this celestial theater. But even mid-latitude dwellers as far south as 40 degrees New York, Madrid, or Tasmania may glimpse the lights during potent storms. The next 2 years could redefine what it means to chase the aurora, a natural wonder that binds us to the cosmos in moments of quiet awe. Yet, as the sun paints our skies with fire, other visitors approach from the interstellar deep, each carrying its own mystery. 3 green glowing comets race toward us, one poised to blaze bright enough for the naked eye. And looming in the shadows, 3 Atlas, its anomalies unresolved its trajectory. A question mark prepares to emerge from the sun's embrace, carrying answers that could either affirm our understanding or upend it entirely. The heavens are alive with portents, and we stand at the threshold of revelations that could redefine our place in the stars. Chapter 13, Comet Chaos 3. Emerald envoys ignite the October sky. October 2025 unfurls like a velvet curtain on a cosmic stage, where the night sky pulses with an otherworldly allure. Tilt your gaze upward on the clearest evenings from a vantage point kissed by darkness, and you might behold not one, not two, but a trio of spectral visitors streaking through the heavens, all aglow in an ethereal green hue, each unearthed from the void just this year. These are no ordinary wanderers. They are harbingers of the solar system's ancient secrets, icy relics from forgotten epochs now awakening in a blaze of borrowed sunlight. And among them, one may soon tease the unaided eye, a rare celestial jewel, In an age where most comets tease from afar, forever faint and elusive, this convergence is no mere coincidence. It's a symphony of the stars, a fleeting gift that whispers of the universe's boundless caprice. At the heart of this emerald parade stands Comet C 2025 A6 Lemon, the undisputed luminary of the show, christened after the vigilant gaze of Arizona's Mount Lemmon Observatory, where it flickered into existence on January 3, 2025. Back then, it masqueraded as a mere asteroid, a ghostly speck at magnitude 21.5, so dim it barely registered against the cosmic backdrop. Follow-up scrutiny unveiled its true guise, a condensed coma veiling a nascent tail, the unmistakable signature of a comet rousing from slumber. For months, Lemon lingered in obscurity, dutifully catalogued by professional sky hunters, but dismissed by the wider world as just another fleeting phantom. Initial forecasts painted a modest portrait, a peak of magnitude 9 near perihelion in early November, a whisper for backyard telescopes far from the naked eye's embrace. But comets, those capricious nomads of the deep freeze, defy prophecy. In mid-August, as Lemon shrugged off the sun's blinding veil after solar conjunction, it erupted in defiance. Observers gasped at its audacity, brighter than any model dared dream, surging to magnitude. 11 by August 19th, a spiky tail etching its presence like a comet's defiant quill. The ascent didn't falter. By late September, it gleamed at magnitude 8 to 9, a hazy beacon for binoculars and small scopes. Astrophotographers, those modern alchemists of the night, immortalized its splendor, a radiant nucleus cradled in a swelling coma, trailed by a sinuous ion tail unfurling against the solar wind, twisted with knots and curls like the brushstrokes of a celestial artist. By September 30th, Lemon had ascended to magnitude 6.6, its ion tail sprawling 3 degrees across the firmament, a vast arc visible to the patient eye, while a dust tail began to tease the horizon. As of mid-October, fresh sightings peg it at magnitude 5. 0, a fuzzy sentinel, 15 degrees below the Big Dipper's handle, grazing the star core Caroli like a whispered secret. Updated ephemerides refreshed with each dawn's data prophecy, a crescendo to magnitude 4, perhaps even 3, as it hurtles to Earth's doorstep on October 21st, a mere 56 million miles distant. From pristine dark sky sanctuaries, far from urban glows, adventurers may spy it unaided, a soft emerald smudge masquerading as a wayward star. Positioned 42 degrees from the sun's glare, it graces the western evening sky an hour after twilight, a verdant lantern in the deepening dusk. Lemon's drama peaks beyond this rendezvous. As it barrels toward perihelion on November 8th, its solar proximity will stoke further brilliance with the finest spectacles unfolding around Halloween into early November. It will glide through the constellation of Fomalhaut's watery realm, Piscis Austrinus, a siren song for northern hemisphere stargazers. This is no routine pass. Lemon traces an orbit of exquisite elongation, a 350-year pilgrimage that may never loop back in our lifetimes or humanity's for that matter. A once-in-a-cosmic-era apparition, it beckons us to witness the birth pangs of a star system long extinct. Yet Lemon doesn't command the stage alone. Its verdant siblings amplify the chorus. Enter Comet C 2025 R2 Swan, an audacious latecomer unearthed mere weeks ago on September 11, 2025 by eagle-eyed amateurs Vladimir Bezugli and Michael Matiazzo. They spied it in the ultraviolet whispers of NASA's Solar and Heliospheric Observatory, SOHO specifically. The Swan instrument solar wind anisotropies designed to chase the sun's ethereal breath. This comet slipped past detection until the eve of its solar tryst, veiled by the sun's tyrannical radiance. Perihelion claimed it on September 12th, a hair's breadth from discovery at 0.5 AU, where it blazed at magnitude 7.3. Its tail, a 2-degree banner of defiance. Now receding from the sun's clutches, Swan won't chase Lemon's heights, but its retreat gifts us clarity. On October 20th, it brushes Earth at 24 million miles, a fleeting intimacy that could nudge its glow to magnitude. 6 teetering on naked eye visibility under flawless skies, though binoculars will coax its secrets more readily. Stunning frames already capture its tail lancing past Spica, the virgin's ear of corn, a luminous duel in the twilight. This weekend, it dallies within a degree of ruddy Mars, a crimson-green tableau ripe for the lens where astrophotographers can ensnare both in a single frame, a cosmic pas de deux etched in starlight. Rounding out the triad is comet C2025K1, Atlas, a subtler player named for the asteroid terrestrial impact last alert system. Atlas, that tireless sentinel against cosmic intruders. Spotted in May 2025, this Oort cloud exile is the faintest of the flock, yet it stirs with promise brightening as it nears the sun's forge on October 8th at a perilous 0.33 AU inside Mercury's domain, where disintegration looms like a shadow. If it endures this solar baptism, it re-emerges for pre-dawn patrols in the coming weeks, a turquoise whisper in Virgo demanding binoculars or small telescopes for the devoted. Its coma gleams faintly, 2 tails hinting at the tempests, within a resilient understudy in this green ballet. Why do these harbingers don the emerald mantle? The alchemy lies in diatomic carbon C2 twin atoms forged in the comet's icy heart. As solar fury warms their frigid vaults, radiation fractures larger organics, liberating C2 into the coma. There, it drinks ultraviolet light and exhales in a spectral serenade green wavelengths that dance for human eyes, a fluorescence born of stellar breath. The nearer the sun, the richer the release, the deeper the verdant veil. It's a signature of comet's wild chemistry, a fleeting iridescence that turns frozen wanderers into living lanterns. Curiously, a 4th emerald phantom lurks the interstellar enigma, 3i Atlas, only the 3rd confirmed exile from beyond our stellar fold. Once crimson in its aloof detachment, it shed that ruddy shroud in September 2025, blooming emerald during the blood moon's eclipse on the 7th. Captured by astrophotographers in Namibia, its gas-rich coma spanned 2 arc minutes, a blue-green aura defying its earlier spectra, no dicarbon detected yet glowing all the same. Is it cyanide's surge or an alien brew we can't yet name? This shapeshifter with its anomalous plumes and sunward tail joins the fray as October wanes a wild card from the galaxy's edge. Comet Lemon, in particular, has eclipsed all auguries, its vigor a siren call to astronomers. Nick James, steward of the British Astronomical Association's Comet Vigil, confided to spaceweather.com. This comet is developing very nicely, and it is already an impressive object well placed for observation in the morning sky. It is definitely worth getting up for. Comets are the mavericks of the heavens, untamed, unpredictable, prone to outbursts that shatter forecasts or fades that mock our hopes. They are tempests in ice surging with sudden fervor, splintering in the solar rage or dissolving into whispers when glory beckons. To divine their dance is to court the whims of chaos-educated gambles, laced with the thrill of the unforeseen. And in October 2025, the surprises cascade 3 green specters in tandem, one flirting with unaided sight. This celestial riot unfolds against a tapestry of turmoil, the sun's furious gasps birthing auroras that bleed into mid-latitudes asteroids, ghosting our defenses like uninvited shades, a Martian stone etched with life's faint echo. Yet amid the natural maelstrom, human ambition stirs. One audacious venture readies its thunder, the mightiest rocket ever forged, a colossus poised to either shatter the bonds of Earth or etch itself into the annals of hubris. As the comets streak and the skies ignite, we stand on the precipice, eyes aloft, hearts alight with the ancient hunger to touch the infinite. Chapter 14, Starship's Final Act, SpaceX's Make or Break Moment, October 13th, 2025. Circle that date in blazing red, for it marks a crucible where ambition and physics collide, where the audacity of human dreams faces the unyielding verdict of reality. If the stars align, and with SpaceX that's a gamble as precarious as threading a needle in a hurricane, the world will stand witness to the 11th test flight of Starship. The towering colossus that claims the title of the tallest, most powerful rocket ever forged by human hands. At 400 feet with thrust enough to shake the Earth, it's a monument to hubris and hope, a stainless steel titan meant to rewrite the rules of space. But this launch isn't just another chapter in SpaceX's saga. It's the swan song of Starship version 2, the scrappy prototype that's endured a gauntlet of fire failure and fleeting triumph. What comes next? Version 3 promises to be larger, fiercer, a leap toward operational glory. The question burning in the minds of millions is whether version 2 can exit the stage with a roar of triumph, or if it will succumb to one last spectacular explosion in a year already scarred by too many. Let's confront the brutal truth. 2025 has been a merciless crucible for Starship, a year that's tested the resolve of Elon Musk's visionaries and their legion of believers. The campaign began with a double blow, two catastrophic failures that rattled confidence like seismic shocks through the aerospace world. Flight 7 launched on January 16th under the crisp Florida sky saw its upper stage Ship 33 meet a fiery end mere moments into its ascent burn. 4 of its 6 Raptor engines, the beating heart of Starship's ambition, shut down prematurely in a cascading failure that sent harmonic vibrations ripping through the craft. The loss of attitude control was swift telemetry severed in a blink, and the vehicle disintegrated in a pyrotechnic spectacle, visible from the beaches of Cape Canaveral to the turquoise waters of Jamaica and the Turks and Caicos Islands. The debris field stretched across hundreds of miles, grounding flights and prompting urgent Coast Guard sweeps as fragments rained into the Atlantic. A grim reminder that even giants can fall. Flight 8 on March 6th offered a fleeting reprieve. The Super Heavy booster, Booster 14, achieved a historic milestone, snared mid-air by the launch tower's mechanical chopsticks in a maneuver that seemed to defy physics itself. The control room erupted. For a moment, SpaceX stood on the cusp of a new era of reusable rocketry. But euphoria gave way to dread as Ship 34 faltered mid-burn. 4 engines choked, pitching the craft into a chaotic spiral. 9.5 minutes after liftoff, it fractured over the Atlantic, its wreckage triggering ground stops at Florida airports as shards fell perilously close to populated airways. The pattern repeated with Flight 9 on May 27th, a bittersweet milestone that debuted the program's first reused Super Heavy booster, Booster 14's encore performance. Yet Ship 35 despite clawing past its initial ascent, succumbed to a propellant leak that ignited fires in its aft section, sending it tumbling into oblivion over the Indian Ocean. 3 upper stages lost 3 investigations, launched 3 waves of redesigns, each accompanied by fervent promises that the next flight would rewrite the narrative. Critics sharpened their knives, whispering that Starship was a dream too vast a machine, too complex to tame. Then came Flight 10 on August 26th, a phoenix rising from the ashes of despair. Booster 16 executed a flawless splashdown in the Gulf of Mexico, while Ship 37 traced a perfect suborbital arc, its heat shield enduring the re-entry inferno with stoic resilience. A controlled landing in the Indian Ocean capped the triumph, but the mission's crown jewel was its mid-flight feat: the deployment of Starlink simulators, mock satellites that validated the payload bay's mechanisms for future constellations. For the first time in months, SpaceX's engineers, battered but unbowed, could breathe. Musk himself took to exhaling it as a critical capability demonstration, a beacon of hope amid the wreckage. The world took notice. NASA, tethered to Starship for its Artemis 3 lunar landing in 2027, exhaled alongside them. Now Flight 11 looms on October 13th, 6:15 p.m. Central Time from the salt-crusted launch pad at Starbase South Texas. A mission that mirrors Flight 10's blueprint, but dares to push further into uncharted territory. The booster B-15 is a grizzled veteran of Flight 8's March triumph, its 24 flight-proven Raptor engines, a testament to the grind of reuse under cosmic stress. This time, no tower catch awaits. Instead, B-15 will pioneer a landing burn choreography destined to shape version 3's future. The sequence is audacious. 13 engines will ignite for the initial descent, a blazing chorus to arrest its plunge. Then, in the critical divert phase, it transitions to a 5-engine configuration, up from the previous 3, to bolster redundancy against the spontaneous shutdowns that have haunted prior flights. Finally, the booster will narrow to its 3 central engines, achieving a full hover above the Gulf of Mexico, before silencing its fires and plunging into the sea. SpaceX dubs this a stress test, a deliberate probe of vehicle dynamics as engines cycle through shutdowns and restarts in real-world chaos. If it holds, engineers murmur, it's a cornerstone for version 3. If it falters, the Gulf swallows the lesson, not the pad. Ship 38. The upper stage carries a manifesto as bold as it is perilous. 8 Starlink simulators, precise replicas in mass and form of the next-generation constellation, will spring from its payload bay, testing the intricate ballet of deployment doors and sequencing for commercial missions to come. These dummies won't orbit. They'll ride the suborbital arc and burn to ash on re-entry. But their release is a dress rehearsal for the fleets that will blanket the skies with connectivity. Next, Ship 38 will attempt a Raptor relight in the vacuum of space, a fleeting ignition to prove it can maneuver beyond mere coasting of vital skill for lunar orbits, Martian injections, or any voyage demanding precision in the void. Then comes the Crucible, a heat shield deliberately maimed with tiles stripped from critical flanks to expose the ship's steel skin to re-entry's plasma torrent. Some gaps pierce to the core, bereft of ablative backup. If the Inferno finds a seam, it could carve through like a blade, inviting catastrophic failure. We need to know. The breaking point, SpaceX's team insists the exact moment resilience yields to ruin. Only by tempting fate can we forge invulnerability. Should Ship 38 survive the plasma gauntlet, a dynamic banking maneuver awaits in subsonic descent, honing guidance algorithms for the pinpoint landings of tomorrow's catch and reuse era. A final landing burn aims for a gentle splashdown in the Indian Ocean hole if the aerodynamics align, shattered if they don't. Every move is a stepping stone to version 3 elongated hulls, swollen with propellant payload bays, yawning to swallow greater cargoes, boosters bristling with additional raptors to unleash thrust that could humble mountains. This iteration distills a decade of lessons, 11 flights, 5 fiery demises, countless explosions and near misses that carved wisdom into scorched metal. Version 3 is the dream made manifest, a rocket to make orbit as routine as a morning commute to seed Mars, with human footprints to birth satellite swarms in barrages to refuel in orbit like a pit stop in the stars. But Flight 11's shadow looms vast and unforgiving. A Ship 38 unraveling under re-entry's wrath would arm detractors with fresh ammunition. Fundamentally flawed, they'd crow casting doubt on the Artemis 3 timeline, where Starship must cradle astronauts to the lunar surface by 2027. A booster, botching its novel landing burn, could unravel the reusable gospel sowing seeds of skepticism about version 3's viability. And in an age where every launch streams live to billions, a public catastrophe, flames blooming across X feeds from Tokyo to Timbuktu, could fray SpaceX's pact, with regulators stalling the relentless cadence Musk demands. The stakes aren't just technical, they're existential. Starship is no mere rocket, it's the fulcrum of a vision to unshackle humanity from Earth's cradle. It promises orbits as cheap as airline tickets, Martian cities rising from red dust satellite constellations, weaving global webs, and voyages to realms that linger in the pages of science fiction. But first, it must conquer its own fragility. It must stop exploding. The launch window cracks open on October 13th, a 75-minute portal to destiny. Cameras will swarm Starbase's weathered towers, drones buzzing over the Gulf feeds, streaming from Sydney to Sao Paulo. In the breathless hush before the Raptor's apocalyptic roar, a global prayer will rise, unspoken but universal. Please don't blow up. Success or scar. Version 2's curtain falls, yielding to a lineage poised to redefine the stars. Yet, as SpaceX wrestles its iron giant toward maturity, another nation's probe hurtles through the cosmic dark billions of miles from Earth, chasing a relic of the moon's violent birth, a mission whose revelations could rewrite the scars of our satellite's fiery genesis, and perhaps cast light on the enigmas like three-eye Atlas that still haunt our skies. Chapter 15. China's Moon Mystery, Tianwen-2's Daring Odyssey. In the velvet hush of a pre-dawn May morning on the 28th at precisely 1:31 a.m., local time, a Long March 3B rocket pierced the starlit canopy above the Jichang Satellite Launch Center in China's verdant Sichuan province. Flames erupted from its base in a controlled inferno, propelling the sleek payload skyward on plumes of ionized fury, a fleeting streak against the eternal black. To the slumbering world beyond it was a whisper. A routine liftoff in the annals of spaceflight, eclipsed by earthly headlines and fleeting news cycles. But cradled within that rocket's embrace lay a vessel destined to unravel one of the solar system's most tantalizing enigmas. Is a shard of the moon itself adrift in Earth's shadow, masquerading as an unassuming asteroid? a silent witness to cosmic cataclysms long past. This is the saga of Tianwen-2, China's audacious probe into the void, a mission that could rewrite the moon's scarred biography and etch Beijing's name deeper into the ledger of stellar explorers. Tianwen-2, its name evoking the ancient poet Qu Yuan's celestial inquiries, Questions to Heaven, stands as the second pillar in China's burgeoning planetary odyssey. The Tianwen series that probes the cosmos with relentless precision. Its predecessor, Tianwen-1, stormed Mars in 2020, delivering an orbiter, and the indomitable Zhurong rover, whose tireless tracks still carve secrets from the red planet's dunes, operational, even now defying the odds of dust and distance. Tianwen-3 looms on the horizon, a bold bid to snatch Martian soil and return it to Earth, potentially eclipsing NASA's beleaguered Mars sample return program, mired in budgetary quagmires and delays that stretch like Martian canyons. Tianwen-4 envisions an even grander arc, a grand tour to Jupiter's swirling tempests and Uranus's icy veil, a single craft chasing the outer giants in a symphony of gravitational pirouettes. But Tianwen-2 turns its gaze not to distant worlds, but to a phantom in our own celestial backyard, a target so elusive, so intimately bound to Earth that it blurs the line between satellite and stranger. That quarry is 469219, Kamo-o-Alewa, or asteroid 2016 HO3, a celestial oddity astronomers dub a quasi-satellite. Discovered in 2016 by the vigilant eye of Hawaii's Pan-STARRS telescope, it orbits the Sun in a hypnotic pas de deux, with Earth its path so finely tuned that from our vantage it seems to pirouette around our planet like a reluctant moon, and neither fully ensnared by Earth's gravity nor flung to freedom. Kamo-o-Alewa lingers in a stable horseshoe loop, never venturing farther than 0.1 AU, about 9.3 million miles, nor closer than 38 million miles, a ghostly companion that's shadowed us for at least a century, perhaps millennia, its origins shrouded in the fog of time. Roughly 40 to 100 meters across, akin to a Ferris wheel suspended in the void, it completes a solar lap every 365 days, mirroring Earth's year with eerie fidelity. Yet its true strangeness lies in its skin. Spectral analysis reveals a reflective signature uncannily akin to the weathered basalts and anorthosites of lunar highlands pocked by eons of micrometeorite scars. And earlier that year, the Office of Management and Budget, alongside acting NASA administrators, issued orders to slash the agency's workforce by over 4,000 $, a staggering 20% of its talent. From late September through January 9, 2026, seasoned employees accepted deferred resignation offers, marking not temporary furloughs, but permanent losses. Among them were irreplaceable minds engineers shaping Artemis systems, scientists steering planetary missions, and experts in propulsion power systems and life support. At Johnson Space Center in Houston, an anonymous employee revealed the agency lost a leading power systems expert, a devastating blow to the nuclear reactor critical for lunar exploration. This exodus stemmed from relentless budget uncertainty and political pressure. President Trump's proposed 2026 budget delivered a gut punch, the lowest NASA funding since 1961, when Alan Shepard pierced the heavens as the first American in space. The proposal slashed NASA's science programs by a crippling 47%, threatening to cancel 41 missions, many already soaring through space, delivering groundbreaking discoveries. These weren't hypothetical projects, but active spacecraft telescopes, peering into distant galaxies, probes exploring alien worlds, satellites tracking Earth's climate. The cuts would silence spacecraft, like the Chandra X-ray Observatory, a cornerstone of astrophysics since 1999, and even threaten the iconic Hubble Space Telescope. The Nancy Grace Roman Space Telescope, poised to uncover thousands of exoplanets and map billions of galaxies, faced cancellation despite being nearly complete. The OSIRIS-APEX mission en route to study asteroid Apophis during its 2029 Earth flyby would be abandoned mid-flight. The Mars Sample Return mission, with samples already collected on the Red Planet, risked being scuttled, potentially handing China the lead in retrieving Martian material. The devastation extended beyond exploration. Earth science missions monitoring climate change, deforestation, sea level rise, and disaster response faced annihilation. Planetary defense programs, vital for tracking asteroids like the recently undetected 2025 TF, would see slashed budgets, an irony not lost on those aware of the risks. Whistleblowers within NASA decried these moves as illegal, accusing the administration of bypassing Congress and violating constitutional principles. One insider raged, NASA's legal office should know better. This breaks procedures, regulations, and the will of Congress. Yet the violations persisted, shrouded from public view. The human toll rippled outward. Universities dependent on NASA grants faced collapsing research programs. Professors scrambled to fund their teams while graduate students lost scholarships mid-degree. Decades of expertise vanished as scientists and engineers left the field entirely. UV astrophysicist Stephen McCandless of Johns Hopkins, who leads NASA's sounding rocket efforts, described the chaos. The disruption has changed the calculus of available funding. His program, backed by a major institution, secured emergency university funds to survive, but smaller programs at less resourced universities had no such lifeline. International partners, too, watched with growing unease. NASA's collaborations with the European Space Agency on missions like Mars Sample Return and Artemis relied on trust and shared investment. Unilateral cancellations and delays strained these hard-won partnerships, tarnishing America's reputation as a reliable ally in space. The deepest wound, however, was to public trust and scientific momentum. Space exploration is a marathon, not a sprint. Missions demand years, sometimes decades of planning, building, and execution. A planetary probe can't be paused mid-journey. A Jupiter mission can't wait for political squabbles to align with orbital mechanics. Every cancelled mission is a discovery lost forever. Every departing expert takes irreplaceable knowledge. Every shutdown fractures momentum that takes years to rebuild. Yet, amid the gloom, a spark of defiance burns. Protests erupted outside NASA's Washington, D.C. headquarters, with employees and supporters demanding full funding and an end to the cuts. Bipartisan lawmakers, especially those from districts housing NASA facilities, rallied against the administration's proposals. The House and Senate drafted appropriations bills exceeding the president's request, though, as of early October, no final agreement had emerged. The question looms: will Congress wield its constitutional power to protect NASA's legacy? Will the public demand that their leaders safeguard the agency that gave us moon landings, Mars rovers, and telescopes that unveiled the universe's wonders? NASA stands at a precipice. One path leads to renewed exploration, scientific breakthroughs, and American leadership among the stars. The other descends into managed decline, abandoned missions, and a future where other nations claim the cosmic frontier. This choice lies not with scientists or engineers, but with politicians and bureaucrats, many insulated from the consequences of their decisions. Meanwhile, those who've dedicated their lives to unraveling the universe watch their